Welcome. Welcome back to my channel Conquer the Fear. In this video, we are going to discuss about how you can do the SQL optimization if you are a Java developer or a Java professional. So in this video, I'm going to explain each and every problems and what are the solution to it. So how you can apply this particular solution in your real world application. Most importantly, I'm going to discuss about what is the problem, how is the solution looking after the problem has been applied. So I'm going to explain you with the code examples, with the code walk you through, with each and every line explain what is the solution to do and how you can do it in your application. Before we move on, if you are liking my content, please subscribe for more such videos which will motivate me to make such more content and give value to you all. Or you are here for your increasing your knowledge with respect to how you can optimize the SQL in your Java, then this is the right video. And this is one of the most frequently asked interview questions for the Java professionals. So you need to have a deep understanding of the database, how it works, and how to improve those. So I'm going to discuss what are the techniques, how you can practically improve your application performance. Now, if you look at the very first thing, what we are going to discuss about why SQL optimization is crucial in your application, because if your application is an enterprise application, it is definitely going to interact, and the primary reason or the primary bottleneck would be the performance. If your SQLs are unoptimized, the queries are unoptimized, then it can lead to different problems. So the very first problem is slow responsiveness. So the user is going to have a delay in the response, where he is going to face a lot of problems. Then the high resource consumption, the database servers and the application servers is going to be overloaded. It is going to consume the CPU. There is a lot of memories and IO being consumed up, so it is going to consume lot of the resources. Then comes the scalability issue. So there will be a user is going to explain the load of increasing the application is going to fail, because it is going to fail to handle that particular demand. It is going to lead to the crashes, or there is some performance degradation is going to happen in your application. Now, the infrastructure cost is going to be increased. So, the more powerful and the expensive the hardware, it might also need to be compensate for the inefficient query. So, the reason, if you are being having the expensive and the powerful hardware, that in spite of that, if your application is not optimized, it can lead to that particular issue. Then comes the deadlock and the concurrency issue. What happens if your applications are writing it the transaction in a poor manner? It can lead to database deadlocks. It can severely impact your application's availability. So to understand and apply this particular optimization techniques, you need to have a strong foundation of how to build the robust, scalable, and performance applications. So in this video, I'm going to explain that how you can increase your application SQL optimization techniques, when especially if you're dealing with Java and SQL. So this is also one of the most sought or one of the most important interview questions asked, where he will try to understand whether you have done SQL optimization, whether you have increased your application performance. Now, interviewer, you may like try to look your knowledge in these particular areas. First, you will try to check, do you know the database fundamentals? So, are you aware of the concepts like indexing? There are indexes who improve the performance. There are different types of indexes. What are the indexes types, and what is the difference between them? When to use them actually? So, before, I mean, if you are knowing what exactly are indexes, you should also know why to use it and where to use it. So, normalization and denormalization, you need to have a strong understanding of that. Then comes like table design. So you need to have appropriate data types assigned to them. The primary key and the foreign key relation should be defined, so that you have that particular proper data segregated. You should have an implementation and understanding of asset properties and the transaction, how they are going to impact your concurrency and the performance as an overall your application, consistency and availability. Now you also need to have a strong understanding of how to optimize your SQL. So you need to have understanding of SQL as a whole, where this particular techniques can be used up. Now if you see, like, as an examples, SQL star, that is SQL star means you are trying to retrieve each and every column from that particular table. Then the opposite of that is you are trying to retrieve only specific queries. So these technique of retrieving only specific can improve your performance. Then you need to be a very efficient with the where clause. So you need to avoid some functions, you need to use some appropriate operators wherever when required. You can use some various join strategies, like you have inner joins, like left joins, and unnecessary joins should not be written for just for writing the query. Then exist or inquiries for subqueries when you're writing, that you have to check. You need to have understanding of union and union, or what is the difference, how you can write those and when to write those. Batch processing for the DML insert, so you can insert, update and delete in the batch wise, so that it can improve your performance. And store procedures. Now these are all advanced level SQL questions. So a store procedure comes like after you're writing the queries and you want to perform more number of operations in a single go. In that way you can do lot of things in the procedures. Then you need to aware of that. Then comes the you need to analyze your execution plan. So you need to explain how you're going to execute it, what are the techniques, etc. Database specific best practices. Now you need to have a connection pooling implemented. Why this connection pooling is important, what are the common libraries available. If you have Hikari CP is there, Apache DBCP is there. You need to make use of the prepared statement. So what are the benefit when you are using this particular, what is the security aspect of it. You need to have an understanding of that part. Then the resource management. So you need to, how you can close the connection, how the statements are executed, how the result set objects are being taken up and then used for your application. Object relational mapping tools, you need to be aware of those, like we have Hibernate as an implementation, JPA as a specification. So how this Hibernate can improve your SQL generation, how it can optimize it, that understanding you need to have. Then you should always try to avoid n plus one problem. So common, it's an anti pattern which commonly you should be avoiding, and you should be using the alternate strategy for it. Caching mechanism, there are application level caching which you can reduce your database hits by using this particular providers. Now let's look at the common SQL performance issue and what are the solution to it. Now I'm going to explain each and everything. So watch this very carefully. Now there are some optimization techniques. The very first thing is full table scans. Now when your query needs to retrieve every row in a table and to find some data, the what you can do is that you can create a index on top of that, so which is going to be frequently searched up. So you can add a where clause, you can order it by, group by, or joins you can use in this clause, so that can improve your performance. Now let's say you have too many rows to be retrieved. So the data, the solution to this is that you need to have a specific column to be selected instead of retrieving SQL star and all of them. And you can restrict your limit, or you can have that particular pagination offset implementation in your query or in your logic. Now if you're trying to do an inefficient joins, then there are, you're trying to join, let's say, 3 4 tables, 5 tables, and you're not writing your joins in efficient way, or efficient conditions are not introduced, there will be a problem. So the solution to it, that you can optimize your joins, you can use the correct joins, whether it is inner, left, right, or full outer join. You can consider denormalization for your frequent accessing tables. You can highly join that particular. using the join. Then we need to look at the inside loops over there. So there are some query loops. Let's say the n plus 1 problem. Executing the database query for each of this particular iteration can be cumbersome. The solution is you can make use of the batch fetching. So instead of loading the data one by one and hitting the database, connecting it, and then retrieving it, you can do the batch processing. You can use the SQL join so that you can retrieve in a single go, in a single query. Now, if you are not using the prepared statement, that is going to be a problematic, because it is you will expose your SQL, your code for an SQL injection attack. So make sure you are using the prepared statements. Then we have to make use of the connection pooling. So always opening and closing the connection is quite important. So it's quite overhead when you are trying to establishing the database connection, you are trying to close the database connection. So there are a lot of resource is being utilized. The solution is connection pooling. So efficient connection pooling. Then you have to have a suboptimal where clause. So you need to understand where this particular indexes are being applied, what are the or conditions, when to use that, etc. Then it will perform better. So the solution is to avoid functions in the where clause, where you're trying to index columns on the index columns basically. So either convert that into an union all, if it is an, or you can use exist instead of an inquiry. That will give a better performance. Now if you are having large number of inserts, that is also going to increase your overhead, because you're trying to insert a operation in a single time, every time the same operation in a every time, right? So you should make use of the batch processing, as the process is similar and you can insert or update everything at once in a single query. Now let's look at the before and after examples. When you're dealing with Java, I'm sure you must have faced these particular problems. So your application, when you're trying to run it, it then goes from your connecting to the database, and it's, gradually what happens, your application start degrading. Now we'll look into what are the common problems before the solution, and what are the problems after we applied, and what are the solution after we applied this, what is going to be the improvement in it. Take the first example, that is full table scan versus indexing. Now what happens when you're trying to retrieve, let's say you have an email ID which you are trying to retrieve from for the user. So if your indexes are not applied on the email column, the database might have problems to fully scan that particular email, and then especially if it is very large table, then it is going to take a forever for it to retrieve. So in that case, what you have to do, you have to apply the indexes. Now here as an example, I will show you the table which is here. So here if you see, there is an ID, there is a username and email. Now let's say there are some millions of records in it. Now if you want to search something, it is going to take a long time to retrieve, because the create table is created using the column with no index in that. So let's look at the Java code. If your table has got no index, now let's look at the examples. Now this example is about before applying the index. Now here if you see, there is a main class written over here, there is a main method, and under this if you see, there is a user created, and with that particular user, in this particular before index class, I have written one method over here. So whenever you are trying to create a user or to get the user from the database, I'm going to pass on this particular details, and then ultimately it is going to come into this particular query, it is going to apply this particular here actually the email over here, and then it is going to execute that particular statement, and then it is going to retrieve it. Now if you have no indexing applied, then there is a problem, because this query will return, it will try to find by each and every row, and then it will take little bit time. But if indexing is applied on this particular column, let's say the email over here, then it will quickly retrieve it. Also if you take a look at this, I'm trying to make use of a statement over a normal SQL query over here. there is no prepared statement applied over here. So this is also one of the problem. You need to make use of the prepared statement over here. Also, if you see, the try and catch is written over here, but there is also a better version that is trying to close the connection automatically. We can make use of the try with resources, so it can prevent the memory leaks. And when you are using the prepared statement, it is going to improve your performance, because we are trying to execute the query with the parameter based, and it is a pre-compiled one. So that is going to save time from every time your code being compiled, parsing it, and then compiling it, right? So it is can increase, or no, it is going to be an increasing overhead over here. So that is going to be the problem, and indexing applied on this particular column is going to improve it. Now let's look at the version after we implement that particular indexing. Now this is the same example, same set of things what have we applied over here, but there are a lot other changes. First is indexing, what we have applied it over here on this particular column. Okay, and second, if you see here, I am trying to have this particular resource try with resource over here. Now earlier, if you look at the code, it was without the try with resources. So in this case, your memory leaks or connection leaks are not, it is automatically closed up the moment the code snippet is completed from that. So here you are trying to ensure your resources are getting closed up automatically. And to the query, the change, if you see, there is an parameter added over here. Now with use of the prepared statement, I'm trying to add that particular parameterized in over there. So this is going to prevent your SQL injection. So if you have heard of the famous problem of SQL injection or SQL attack, injection attack, so this is going to stop that. And in that, after that, it is going to retrieve that particular value from it. So this is going to be a significant improvement as compared to the previous version what we saw. So if you look at here, this index was created on that particular column, that is the user table and the email. Hence, whatever we discussed is going to improve the performance. Let's look at the second problem. Now we are going to look at the problem that is n plus 1. Now this is also an important interview questions. Most of them are not aware what exactly the n plus 1 problem is about, and this is one of the favorite interview questions when interviewer is trying to deal with the database and wanted to understand whether he has optimized his queries in certain way. So when you're trying to retrieve, let's say, the list of orders, and for each of this particular order, you want to retrieve some customer names. Now, this is what actually the n plus one problem is. So for every orders, whatever it is there will be a subsequent SQL customer name would be retrieved, and there is also a separate query which will be called up. So that's what the scenario is about. That's what the problem is about. So the now let's say or single order has got 50 customers name, example, just for an hypothetical example, then it is going to call that particular 50 times. So that is the problem. So instead of that, you can make use of the join query, or you can actually use some fetch strategies like lazy or eager for that actually to optimize it. We'll look into the before and the after version, but this is for an just set an example of what exactly the scenario would be. Now in your table, you will be having two database tables. One is create customer, and one is, that is the orders over here. Now if you see, there is an ID column over here, then we have customer ID column and foreign key applied. So this is the primary key from the customer is being foreign key for the order table. So that is one being added in it. Now if you look at this problem, we'll first look into the before and what is exactly the code would look out. Here you will see another class written over here. This is the statement or the problem before the n plus 1 is been applied. Now make look at this particular problem very closely. Now you have a customer created, you have an order over here. Okay, and then if you see, I'm trying to get the order with the customer info over here. Now just have a look at this particular two queries being executed. Firstly, if you see the orders, I'm trying to retrieve all the orders from this particular table. Then if you see, for each of this particular order, I'm going to retrieve the customer details. Now if you just try to see here, I'm making use of this try with resource, but if you see here, there is a statement being created. I'm trying to execute this first order statement, and once I get the order, I am trying to loop that particular thing. And on each order, what I'm trying to get is the customer ID, and then from that customer ID, if you see, there is one more try catch block written over here where I'm trying to get the customer making use of that particular prepared statement over here. Now you see, this is going to be an overhead over here, and you need to have a while loop on top of that. Then you're trying to do one more call for each every time. So this is an overhead, and this is also a not optimized way to write a query to fetch that. So SQL provide you a better option to do that. So let's check it out, like uh, when you're having this particular optimized version, how to do implement that. So this is the one what we discussed now is not the optimized version. This is one which is going to create a problem. Now, if you go to the after n plus 1 problem solution, here if you see, the same customer is being added, then the order, and then if you see here in this particular customer, now what are we doing here is that instead of writing two queries, I have made an inner join which will also fetch the orders and also fetch the related customer details. Now in the single query, if you see, everything is taken care in this. So this is a great performance optimization in the query what you do. So if you look at the previous example, there was definitely a time consuming thing. It used to also increase the number of database hits to the queries, right? So using the queries, so here actually in single query you will get all this particular details, and then in the Java you can do this particular optimization logic to be written. So that's where it is completely improvising your code. Now as we mentioned, right, so instead of getting one query for getting all the queries of orders, and then on each order you're trying to then fetch the another customer detail, this solution to be a boon, and a boon for you to solve this particular kind of issues. Let's look at the third problem. The third problem is like individual inserts versus the batch insert. Now, this is going to be a problematic. Let's say you have millions of records of products that are to be inserted into the database. Now, inserting one by one into the database table is going to create a lot of problem, as every time it is going to execute that particular query and update the table or create the in the database. So there is an overhead over there. So instead of that, we can make use of the batch insert instead of trying to insert it individual. Now here you have a table called products over here. We have the ID, name, and the price and the stock over here. So let's look at the before and the after version of the code. Now if you look at this particular problem statement over here, actually you will see there is an add product. So I mean this particular thing list of this here, I'm writing a for loop over here trying to add and insert over here. So let's look at this particular thing. Now here, if you see, I'm trying to add this. See here, what I'm trying to do here, I've added all the products, then I'm trying to add that particular products into it. Now what is happening, there is an insert being happening over here. There is a value, and then I'm trying to make it use of the prepared statement to insert. But here the problem is, for each and every time I'm trying to run this particular execute statement, the prepared statement over here, and then trying to execute it. Now if you see here, every time I'm trying to make a prepared statement, I'm trying to add the values, I'm trying to execute that, and then trying to close the statement. Again, then the next for loop, it is going to again initialize it and then going to run it. So this is a improper way of the implementation, which is going to increase your performance issues. So let's look at the after version. Now instead of doing like that, what we can do here is that we can make use of this particular same thing. Now instead of this particular prepared statement executing every time, we first set it the I mean we'll deal with the transaction where either the all the rows will be inserted, or either there will be a failure, right? So we can actually check out auto commit fail over there, false over here. And then in the for loop I will try to create a statements, set the statements and everything over here. But the change over here is that I'm not trying to execute that particular statement over here. What I'm trying to do, I'm trying to add this to a batch. So let's say there are hundreds or millions of them. It is going to be added as a batch, and ultimately at once I'm trying to going to insert. So this is going to execute once for and forever that particular query, and it will insert in the batch wise. So it is the responsibility of the database to insert that. Now this will be a lot better way to do that. Also, after this everything, there is no exception been happening, it will commit the transaction over here. So that's a performance improved when it comes to processing it using the batch wise. This solution, the first is batch processing. What we have used is going to increase your reduce your network overhead. It is going to reduce your database processing time, etc. And also the round trip which is going to happen from back and forth within the database. So the network is going to save, the memory is going to be saved, the processing time is going to save. So there is a win-win situation here. Then the transaction whatever we have set it is going to either commit all the inserts, or either it is going to fail if there is only a failure inside. So in this way you're trying to improve the consistency and also trying to reduce the number of commit operations to the database. So this will overall improve your application performance. Let's look at some of the interview tips which you need to take care when you're trying to attend an interview, and how you can answer them. Now, first thing, when you're dealing with especially Java and SQL and the performance of your SQL side, you have to understand uh, what exactly it is, and most importantly why are you using that. So always try to explain to the interviewer that what is the problem, how we can solve it, and why exactly we need this as a solution over there. So always try to explain the why part over there, which is going to explain, like, what is the optimization work happening, or what exactly it solves it. Then we can actually explain what are the trade-offs. So we can tell them that, let's say for the indexes, that's an example, it is going to now speed up your reads, it is going to slow down the writes and other things, right, if the indexes are not being applied properly. So denormalization will improve, will read your increase your performance, and also if it can also make it less complicated when you are trying to have this particular indexes applied. So mention those particular details. Then you can actually mention what is the crucial query execution plans, what are the bottleneck of, like, you need to first identify what is a bottleneck, so where you will start from there. So you have to mention those things, then discuss about the ORM related, like if you are aware of working implementation, the specification is JPA, and you have worked on the implementation of Hibernate, so please discuss about that, how you can optimize that in Hibernate, what are the different strategies to be used up, like we have fetch type, lazy, eager, join, fetch, etc. And we discussed about batch processing, batch fetching, or also you can use your native SQL query if you're trying to execute queries or a complex query. Then definitely we have to make use of connection pooling, because it is very very important topic, and it will significantly increase your performance in the production. Then you have to ask them to have this particular optimization approach first identified. Then you need to propose the solution, and then explain what exactly the mechanics around it and what is the impact of it. So if you try to explain overall this kind of explanation to the interviewer, he will be having a positive mindset about you, and then there is more chance of you clearing the interview, because you are not only trying to answer the question, you're trying to tell him why this particular solution is the best, or why are you using the solution. If this video was helpful, please give us a thumbs up, and and also don't forget to like, subscribe, and hit the bell icon. Thank you for watching.